Okay, folks. So we saw in that warm up, it was we were given this quadratic equation, and we saw in the warm up that we had a problem. Where did that problem occur? Can someone tell me where that problem occurred? You can put it in the chat. You can just turn on your mic and tell me. I'd love that. Yeah. So under here, the b squared minus 4ac. So we had the A value was 8, the B value was 2, and the C value was 5. So under that square root, we had the square root of B squared, which was the 2 squared, minus 4 times A times C. So the problem was that this, what we were taking away, was bigger than the 2 squared, the 4. So that equaled, was it negative 156, I think? If I remember right. Thanks. So that's where the problem came up in that warm up. And that's what we're focusing on. It is called the discriminant. So the discriminant is b squared minus 4ac. All right? And remember, I'm going to highlight this, your a values right there, your b value, and your C value. So this is where they're coming from. And just as a little technicality, notice when I highlight up here, I didn't highlight the plus, because if the B were negative, we wouldn't write plus a negative. We would just change this to subtraction. So that's why I don't do that. So there are three possibilities when we're talking about the discriminant. If we get a positive discriminant, so that is b squared minus 4ac is greater than 0, we have two distinct real number solutions. Well, yeah, if it's greater than 0. If it's a perfect square, so 4, 9, well, 1 as well, because 1 squared is 1. 2 squared is 4, 3 squared is 9, 4 squared is 16. If it's any of those perfect squares, then the answer to our quadratic formula will be rational solutions. If it's not a perfect square, then we will have irrational solutions. And remember, what that means is that the square root will have something under it that is not simplifiable to a whole number. All right? And that's all right. It just means that the decimal will go on forever in our answer. If the discriminant is 0, so if the b squared minus 4ac equals 0, then we have a repeated real number solution. And what that means is that we won't have two answers, just one. And if you think about the graph of a situation like that, it means that the parabola will bounce off of the x-axis somewhere. So in this situation where the discriminant is 0, the parabola will bounce off of the x-axis. In the situation where the positive discriminant is greater than 0, we will have two real solutions. It could look like that, could look like this. So when the positive discriminant is greater than 0, the graph is going to go through the x-axis twice. When the discriminant is 0, the graph will bounce off the x-axis. And when we have a negative discriminant, that is b squared minus 4ac is less than 0, you will have two complex solutions. And in that situation, the graph will not touch the x-axis. So those are the three situations we have. Are there questions about those three situations that I can answer right now? All right, we have been working for 25 minutes, and that is too long to be sitting and working. So would everyone please get up, move your bodies for 30 seconds to 1 minute so we can get the brain flowing, or the brain flowing. See, I need to move. The blood flowing back to our brains. All right, I'm gonna get up and I'm gonna do some curls right now. You figure out what you want to do, maybe some stretching, whatever. All right, now I'm back on my yoga ball, so I'm getting a little bouncing in all the time, engaging my core. So it's a good idea. You guys are learning about something earlier than most people do, and it's that sitting in a chair for a long time can really mess up your body at a desk. So be careful out there. If you have a yoga ball, it's a good idea to use a yoga ball instead of a regular chair sometimes. All right, so we're going to move on from this general discussion about the discriminant and look at some situations. I'm going to go over the first one here and notice that I'm not going to be doing the entire quadratic formula. So we have our A value, our B value, and C value. And in this particular situation, our A is -5, our B is +10, and our C is -5. So when we're finding the discriminant, we will do the B10 squared. So I'm using the discriminant equation right there. Minus 4 times A in this situation is -5 times C in this situation, -5. All right, so the 10 squared is 100 minus 4 times, since I already put that negative right there, I can ignore it now. 4 times -5, that's -20, times -5 is +100. Negative times a negative is always a positive. So minus 100. So in our first situation, we have a discriminant equal to 0. And so what does that tell us? It says to state the number and type of solutions. So, gosh, I don't remember what that tells us. Let me go back to my notes on that previous slide and see what it means when we have a discriminant equal to 0. Discriminant equal to 0. We have a repeated real number solution. So here, this is a repeated real number solution. And it doesn't ask this, but that means that the parabola will bounce off of the x-axis somehow. I'm not saying how it's going to bounce, whether it's up or down, but it's going to bounce somehow, somewhere. We would have to do the entire quadratic formula to determine that. Questions about that problem right there? Zero is the value of the discriminant. That's all we have to do. For this question, it just says find the discriminant and state the number and type of solutions. Thomas, thank you for clarifying there. Great. Other questions about that particular problem? Because now you're going to get a chance to try it on your own. All right. I'm going to give you about 1 minute to do it on your own. So get as far as you can in 1 minute. I'm setting that timer right now. All right, that's time. Is there anyone out there who's willing to share their work this morning? Tell me what to do. I can just write it down as you tell me. Yeah, yeah. So, because the great job, Sam, I really appreciate how clear you were on your explanation there. Did I write down everything as you had seen it? Great, thank you. So, because our discriminant is positive, we can look back to those notes. Let's see, a positive discriminant. If it's a perfect, let's see, it was 68, and we say, well, let's see, square root 68. I can just grab my calculator and do square root 68, and it doesn't come out to be a whole number. So that means that it is not a perfect square. It is not a perfect square. So we have two irrational solutions. So we have two real, and I'm just going to amend this a little bit. It does not need as much amending as the soil in my garden. Man, it does not grow anything. So this is two irrational solutions. Do any of you guys grow gardens out there in the summer? Anybody have families that grow gardens? Ella does. What's your favorite thing from the garden, Ella? I'm a tomato person. Fresh garden tomatoes are the best. Sounds great. Love it. When I was in college, I visited an urban, so it was inside Portland city limits, and it was a totally self-contained house. You guys are going to be grossed out by this. The woman did not have her plumbing hooked up to the sewage. She took care of it all right on property and just went into her compost and fed her garden. It was amazing, totally amazing. So we have two irrational solutions there. Are there any questions about that one, or is everyone pretty good with this discriminant so far? All right. I'd like you to try the next one, if you would, please. About another 15 seconds. Get as far as you can on this. Okay. Anybody out there willing to share? I'd love to hear a new voice this morning. And if no one is ready, that's fine. All right, I'll go through it. So the B here is 14. Whoops, I don't want a highlighter. The B is 14. And we're going to square that. Minus 4 times A. A is negative 11. And C is negative 6. So I'm going to do that all in one step. I'm going to just put it in my calculator exactly like that. 14 squared minus 4 times negative 11 times negative 6. And when I put that in my calculator, I get a negative 68. And when I get a negative 68, I can go back to my notes and see that it is a negative discriminant, which means I have two complex solutions. Whoops. All right. And that is that. Questions on that one? I was just thinking about how I could maybe make this better. Maybe while I have you guys work on problems, I should be pausing the video so it's not recording during that silence, shouldn't I? And then if you were watching the video, you could just pause it and do it. So I'm going to pause the video while everyone does this next problem. And if you're working from home asynchronously, then you should pause your video right here. All right, so great job on that one. And we see there that the discriminant was 100, which means we have two rational solutions. Thank you for that excellent explanation. And we have to talk about complex solutions now. So what happens when we do have, when we're looking at the entire quadratic formula, and when we have a negative discriminant? When we have a negative discriminant, we're going to have two complex solutions, and these solutions are going to always be of a special form. They're called complex conjugates. And remembering that I is equal to square root negative 1, just like Sam reminded us of early in the warm-up, the form of all of our solutions when we have a negative discriminant will be A plus BI and A minus BI. So notice the only difference in those two is that instead of a plus, we have a minus. So the A and the B values in those two are the same. And usually when we're talking about complex conjugates, we just say A plus or minus BI. All right? Questions on complex conjugates or the two distinct complex solutions when we have a negative discriminant? All right. Hey, I see David joined us. David, it's good to see you. These notes will be on our on the canvas just as a reminder, and there's going to be some video there as well for you that you'll be able to go back and check out. So we're going to solve each of these equations with the quadratic formula, and we're going to want to simplify them as well. So I'm going to go through the first one here, and we're going to do it together. That A value is 1. There's a 1 in front of that x squared, even though we don't see it. All right? So here we go. X is equal to negative b plus or minus the square root of b squared. I will only make you guys listen to that song I sing one time. That's enough, I think, for anybody. Minus 4a, a is 1, and c is 5. You know what's hilarious? My kids actually like my singing. So it's one of the best things about having kids is they think you're great. It doesn't matter what you do. So all over 2a, 2 times 1. All right, so now I'm going to do x is equal to negative 4 is positive 4, plus or minus the square root. Negative 4 squared is 16. You know what? I'm going to actually just do that square root in one step like I did before, all right? So let's bring this over here again, and I'm going to do that under the square root. So I have negative 4 squared minus 4 times 1 times 5 minus 4 times 1. I don't need to say times 1. Doesn't help at all. And it turns out to be negative 4. So what I did right there, just so you see, is I took this and I put it into my calculator and I got negative 4. And you should absolutely do that on with your calculator when you're doing these kinds of problems. It's a perfectly fine step. And all of that is over 2. And I'm going to go up here for my next step. And I really like it if you guys, in your work, you do a little arrow like that, giving the reader, the grader, whoever's looking at your work, some indication of the flow of your work. It's really helpful as I'm grading it, or whoever is grading it. So that square root negative 4, so we have the 4 outside, plus and minus. And I'm going to do this step by step. So I'm going to do square root. We have the negative 1 times 4. So I just broke this apart into the negative 1 times 4. And that's all over 2. And now I'm going to break the square root into 2 pieces. Square root 4, yes, I'm doing it in a different order, times square root negative 1 over 2. And now we have x is equal to, actually I'm going to go up to the next little area up here again. X is equal to 4 plus or minus square root 4 is 2, and square root negative 1 is I over 2. And now what I see is the 4, the 2, and the 2 are all divisible by a single number. They're all divisible by 2. So I get x is equal to 4 divided by 2 is 2, plus or minus. 2 divided by 2 is 1, so it'll be 1i, which is just I, over 1. And I don't need to say anything's divisible by 1, so I can just say 2 plus or minus I. And that is my complex conjugate solutions. Those are my complex conjugate solutions. All right. So I'm going to give you guys, let's first ask, does anyone have any questions before you try one of these on your own? All right, I'm going to pause the video and hopefully I'll remember to start it on time next time. All right, let's go over using the quadratic formula to solve here. So I have x is equal to negative b, which is negative 5, plus or minus the square root of b squared, that's the negative 5, squared, minus 4 times a is 7, c is 1, all over 2a, a is 7. Now, the next step is I'm going to take that discriminant underneath the square root, and I'm going to do it on my calculator. So let's bring that up. So under the square root there, you can do the negative 5 squared, but you can also notice that negative 5 squared is the same as 5 squared, and just do 5 squared. I think it's important to write it out as negative 5 squared just as a reminder, but that's one thing you can do. Minus 4 times 7 times 1, which is negative 3. So we have a negative 5 here at the beginning of our quadratic formula, which is 5, plus or minus square root negative 3 all over 14. And so that's going to be x is equal to 5 plus or minus, and that square root negative 3, we can see that there's going to have to be an I there. But square root 3 doesn't simplify at all. It's not a perfect square. It doesn't have any way to simplify it. So really what we have there is 3i, because it's going to be 3 square root, excuse me, that is not right. It's going to be square root 3 times I, because that square root 3 will come right here, times square root negative 1, that negative is the I. And then all of that is over 14. And because we just have a 1 out here in front, the 5, 1, and 14, they're not all divisible by anything. So that's our final answer for our complex conjugate solutions. Do folks have questions on that before you're going to be working on your own for the remainder of the period? All right.